Warahmatullahi wabarakatuh and salam sejahtera. Now we go to the subtopic of 6.3 diesel cycle. The diesel cycle, also known as the ideal cycle for compression ignition engine. So this is the diesel engine. Okay, if we can see at this engine, the engine has 4 strokes, same as Otto cycle, but the differences is here. Okay, in Otto cycle, for the power stroke, it use a spark plug to ignite heat inside this cylinder, but in diesel cycle, we use fuel injector as a Q in. Alright, and the rest of the stroke is the same as Otto cycle. This is the chronology of diesel cycle. If we can see here, we have intake stroke, compression stroke, power stroke, and exhaust stroke. At the intake stroke, we can see that the intake valve will be open and air at the outside will enter the cylinder, and it causes the piston moving from TDC, top dead center, to bottom dead center. And in this position, we said that the volume is displacement volume. What happened next is the intake valve will be closed and the piston will moving from BDC to TDC. Now, the volume inside the cylinder, we call it as a clearance volume. In this clearance volume, it has only air with high pressure and high temperature. Next, we go to the power stroke. In the power stroke, we can see this is a fuel injector. The diesel fuel will be injected through this fuel injector and cause the air inside the cylinder burn. And what happened is the piston will kick out to from TDC to BDC. Okay, lastly, we go to the exhaust stroke. In the exhaust stroke, the exhaust valve will be open and the combustion product will moving out through this valve. Alright. Diesel cycle can be operated at compression ratio of 12 to 24. This is due to the absence of auto ignition in power stroke. This is the PV diagram and the TS diagram. This is PV diagram and this is TS diagram. The differences between PV diagram and TS diagram of diesel cycle and Otto cycle is here. Okay, in Otto cycle, Q in occurs at the constant volume, but in diesel cycle, the Q in occurs at constant pressure. This is the important point that you have to remember. This is the differences between Otto cycle and diesel cycle. So please be careful at this part. Okay, so this is the only differences between diesel and Otto cycle. So the heat transfer to the working fluid is Q in Cp T3 minus T2. Cp because this is constant pressure. Heat addition occurs at the constant pressure. And heat rejected is here. It is the same as Otto cycle, which is Q out is equal to Cv T4 minus T1. Cv because this is constant volume. Okay, so the process is still the same with the Otto cycle, where from state 1 to state 2 is the isentropic compression, where we can apply the formula hijau here. Okay, and constant pressure heat addition, okay, we can use the ideal gas equation from state 3 to state 2 to state 3. 3 to 4 is isentropic expansion, and from this state, okay, 3 to 4, we can apply formula hijau, and 4 to 1, constant volume heat rejection, where we can apply ideal gas equation. So please remember, the formula hijau only apply at the isentropic compression and isentropic expansion. Okay, so to find the thermal efficiency of the ideal diesel cycle, it is the same as a Otto cycle, where thermal efficiency is W net over Q in. So since there is no turbine or compressor here, then we can say that Q net is Q in minus Q out. Then this formula can be reduced to 1 minus Q out over Q in. Okay, now I introduce you one new parameter. Okay, so if in Otto cycle we have compression ratio, but in diesel cycle we have cut-off ratio, RC. C stand for cut-off ratio. Okay, so what is cut-off ratio? Cut-off ratio is the ratio between state 3 to state 2. Okay, state 3 to state 2. Okay, so in this formula, I write the ratio in two ways. One is in capital letter, one in small letter, volume and specific volume. Okay. And at the TS diagram, we can see that the maximum temperature or the highest temperature is at state 3, which is at the constant pressure heat addition. Okay, this is the example of ideal cycle, and this is I will solve this question in another video clips.